Hello, my name is Dr. Alexander Mikhalev, and today we are going to talk about deploying RedisAI on top of RedisGears natural language processing pipeline. A bit about myself. I'm part of data architecture team in Nationwide Building Society. I have extensive background in natural language processing, data science, and data fusion. But today we are going to talk about my fun project, which I have done outside of Building Society with Building Society permission. It started in 2020, where we built natural language processing pipeline as a part of RedisConf hackathon. And the pipeline purpose to help medical professions navigate through medical literature. And it's powered by two ideas. The first one is that when we are looking for medical information, we are interested in things, not strings. So output of the pipeline is knowledge graph. And the second one is that information exploration should be spatial in 3D, virtual reality, or augmented reality. And if you're interested in how to build 3D or VR graph on top of RedisGraph, go watch talk by Brian Vachanga, who is my contributor. Why RedisGears? Core 19 Kaggle dataset for medical competition isn't large by modern standards. It's 15,000 articles, but it's larger than you can process on a single laptop. And that's where RedisGears come into play. RedisGears allows us to distribute compute for up to 1,000 nodes on top of Redis cluster. The steps in the pipeline are pretty standard for NLP, except for this one. The matcher using Karasik automata matches text into medical concepts out of Universal Medical Language System and produces nodes and edges. Nodes, which corresponds to the concept from the medical system, and edges, which are built on assumption that if two concepts are met in a sentence, they form an edge in knowledge graph. And as I said, there is a separate talk on how to surface this information in 3D or virtual reality. But today we are going to augment this NLP pipeline with RedisAI. So we are going to deploy RedisAI inside of RedisGears cluster. And the challenge, the purpose of this deployment will be question answering machine learning models. So I would like to incorporate modern machine learning tools into NLP pipeline, and I would like to start with question answering. So potentially I can extend it into building chatbots, which will talk about medical literature in medical terms. And while creating BERT-based question answering services is quite straightforward, even on such small dataset, you're looking into quite long processing time, and API response will be quite subpar for the user. This is where Redis and Redis modelers comes in picture. So what we are going to do today, we are going to pre-process articles using RedisGears. This is the pipeline which we already built. And we are going to preload models for question answering into RedisAI and RedisGears. And then we are going to create API to run inference for question answering using RedisAI. And what's more important is we're also going to distribute compute on separate RedisGears shards. What is BERT model? BERT stands for Bidirectional Encoder Representation from Transformers. It's created by researchers at Google AI, and it's state-of-the-art in natural language processing tasks, including question answering, our today conversation, natural language inference, and many others. And if you would like to learn more about BERT, there is a link from the presentation on the article describing it. BERT model's use cases include next sentence prediction. This is how your Google Mail autocompletes your sentences. Text summarization, which will be very interesting to explore for medical literature, where you wouldn't want to read the whole article, but you would like to get a meaningful summary out of AI engine. Question answering, the topic of our today conversation. Text classification, and many more. NLP pipeline. How does RedisGears fit into the standard NLP pipeline? Or rather, other way around, how we can map standard steps in our natural language processing into RedisGears. So RedisGears have a set of operations, and the first one is filter. So we detect language and we discard everything non-English. It maps very nicely to filter operator. Then we map paragraphs into multiple sentences. It's a flat map operator. And then we run a spell checker on each sentences. So the sources for documents are OCR. They haven't been spell checked. And if we want to make a meaningful output of it, we have to apply spell checker. And then just to save sentences into hash is the processor. So as I mentioned, what we'll now do, we'll create an API for extractive question answering using BERT model running inside RedisAI. But before we go into creating new RedisAI API, few important points of RedisGears cluster configuration to support machine learning and computationally extensive workloads. So Redis Labs provides RG cluster Docker image and Redis cluster script to easily roll it out. One of the points is make sure that the cluster is deployed in high availability configuration. Each master should have at least one replica. A reason for it is when we will be deploying our machine learning models, we are going to restart masters. And if we restart master and it doesn't have a replica, the cluster will end up in the failed state and you have to manually recreate it. Other parameters are execution time and memory. So BERT models are 1.4 gigabytes. That's where we need to include protobuffer memory, and we need to increase execution time for both cluster and gears shard, because all tasks are computationally extensive, so we need to make sure that we accommodate the timeouts. And now to demo. So first one, I'm going to demonstrate how the 3D part works. So we have a demo page, which is the pattern digital. It assumes that you're typing long, meaningful queries. It's not designed for short string. That's potentially where you can type a query which you will ask normal human being. And the question here is, how does temperature and humidity affect the transmission of SARS 2019? And in response to it, you see there is a knowledge graph representation in 3D. And as I mentioned, so knowledge graph can be viewed, rotated, and each node is the concept from a medical system, and each edge is the sentence and the title of the page where it all came from. And you can see there are multiple sentences supporting single edge because each of the sentences have a corresponding concept in it. And AI VR coming soon. As I mentioned, go watch Brian's talk if you would like to know more details about how it was built. One of the interesting things about presenting knowledge in 3D is that we can go back in time and see how our knowledge and the concepts evolved for around particular type of query. So back to our cluster, and we are going to deploy BERT models in RedisAI in RedisGears. So I already have local RedisGears cluster which have installed RedisAI, and there are corresponding scripts and checklist of how to get it started. As I said, it's a fun project. It's all open source. You're very welcome to contribute. So as a first step to prepare BERT models for loading into RedisAI, we need to trace models and save them into PyTorch. As you can see on the screen, so I'm taking standard transformers BERT for question answering model. I'm specifying the fine-tune instance, which was in addition trained on Squad dataset, question answering dataset, and I return it as a torch script, which is important point for saving it into torch script version. Put model in inference mode rather than training mode. Then we run model against pretty dummy input, and then we say trace and save model as a PyTorch blob. This is pretty standard, nothing interesting, but loading script is slightly more interesting. So what we are going to do here in this script is we are going to obviously read the model, but then we are going to load them into each shard on RedisGears separately. So shards can be accessed in RedisGears via the hashtag. And if you are working with RedisGears, it's one of the most important concepts to get your head around this. You will not be able to save your data into the local shard unless you pass the hashtag as a part of the parameter. And what we are doing here is we are executing gears function, which for each shard returns hashtag. And then we are using these hashtags to save or to load BERT question answering model into each shard separately. So you can see we are setting BERT QA key div hashtag, so it specifies the shard into which we are loading this, and we specify backend torch and device CPU. Obviously, on the supported hardware, we can change it into GPU. So I run those scripts. Now I have RedisGears cluster with RedisAI deployed on top of it, and we loaded PyTorch models into each shard. What we need to do next is to create an API. But before we do it, let's step back. Let's take one step back and think about extractive question answering assumes that the answer to the question is in the context, in the text provided into the model. So if we are going to run this BERT model against every sentence in 50,000 articles, it will be computationally intensive as a starting point, and we'll need ever bigger and bigger cluster. But the second thing is that the user experience will suffer. So the user will get a an output which we then somehow have to rank. So what I have done is I have reused the same things we have built for querying RedisGraph and creating a 3D representation of the query. So I used exactly the same concepts. We take an input from query, we turn it into nodes, and there is a special function which is again powered by the same matcher, which is powered by Karasik automata. It turns it into nodes, and then for each nodes we get edges, which is a list of articles and sentences. And for each of those edges, we are querying them, and then we are passing them into question answering BERT function. So the important point here, we are not fetching sentences at this point. We only fetching keys of the sentences, and we are fetching our favorite hashtag out of the key. So this way, when we call the function QA, and we pass function and the sentence and the hashtag, we know where on which chart it goes. And the QA function looks like this. Yeah, so we have to tokenize our question and the context together. That's why we had to fetch them. There is an opportunity to optimize it, so where we can pre-compute content text inside of Redis chart using RedisAI, but that's outside of this demo, so that will be a very interesting thing to follow up. And so we tokenized inputs, we set it as a tensors, and then we run BERT QA model passing tensors and the hashtag, as I said, is a very important point. So all those things have been stored locally, and BERT QA run locally inside of Redis chart. So I'm going to query, and I'm going to query using CURL API. And then, as you can see, search term is effectiveness of community contact reduction. My local cluster isn't that large, and it's not loaded with many articles. It's about 500 articles. And as you can see, this API produces a response on the assumption that the sentence contains the valid information. And the beauty of this particular response that it have an answer don't know, because it have a fairly limited information. And one of the humorous things I put in README where on larger data set, on running question and answering using exactly the same command, the AI produced sentence, "This would need a tight coordination," which nearly human response to the query. So that concludes the demo. All source, open source, and we can take it into any level of innovation. As I said, it's an open source project, and there are a lot of things we can do to improve it and to improve user experience to it. So now we have a question answering an API. What we can do is we can integrate it with chatbot frameworks, or we can build interface for Alexa or Google Home. We can optimize text using RedisGears. We already have a lot of functions which perform compute, and we know we can use RedisGears function and to perform tokenization and then save token set. Be mindful of hashtag, but there are examples in the code which are working and help you with it. Another topic to explore would be to create summarizations. That will be a really interesting research item because BERT and T5 models are really large memory-consuming models, and making use out of them in a productive setting where it produces results meaningful for medical community will be a very interesting problem. More resources. Project documentation is in old link website because I put an effort into documenting Redis hackathon. I haven't put as much effort into documenting this one. Live demo is live on the server. Overall GitHub repo, the pattern, it leads into all other subrepos, which covers pipeline, API, and it will be a folder for question answering. Join our team on Discord if you want to chat about the project. The key learnings and takeaways I would like you to take from my presentation is that using Redis only and Python, we build knowledge graph from text, and then we build the multiple interfaces to the same knowledge graph. So once you build knowledge graph, it becomes relatively straightforward to build the different types of interfaces which work commonly. All of it using Redis and Redis modules. There is no move in and out of data store for processing. There is a separate instance for RedisGraph, and I populate RedisGraph out of RedisGears on streams. And there is a reason for it, limitations of sharding on Redis graphs. Use Redis for cache. It's really memory efficient and fast. A lot of data science frameworks will benefit from fast cache. RedisGears is really good for processing data without moving data in and out. And you can see the repeated theme here that you don't want to move data in and out because that's one of the most time-consuming processes. And finally, use RedisAI for inference. That's again bringing processing capabilities on data into data store. And RedisAI allows to perform inference without need to move information. Pattern project. So this is a project built as a fun, and it's built for collaboration. Bring your own ideas, bring your own improvements. And on that note, thank you. And I'm really grateful to my team members and to Redis Labs team for helping me to build this demo and presentation. And thank you for listening. Goodbye.